Alright, I hope this video helps you out for Thursday's test. Good luck. So the first one, I'm reflecting across the y-axis. Remember, up and down is the y-axis, side to side is the x-axis. Before the transformation, this is the pre-image. After is the image. I'm reflecting across this y-axis. Don't go across the x, right across the y at a 90-degree angle. My reflected image is going to be over here. So this one to the left, straight across that line of reflection, one box to the right. 3 to the left, 3 to the right. 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5 to the right. 3 left, 3 right. This is called the image. If I look at one point, this is -3, 1, where this one is 3, 1. Notice the y coordinates stay the same, but the x coordinates got opposite. Happens when you reflect across the y-axis. Next one, reflecting across the x-axis. Again, this is the y-axis, x-axis. I'm going straight across this line at a 90-degree angle, always perpendicular to the line of reflection. This point, one box above, one box below. 3 above, 3 below. 1, 2, 3, 4 above, 1, 2, 3, 4 below. 2 above, 2 below. That again is called my image. This is the pre-image. If I look again at a coordinate, this is -3, 1, where the point below it is -3, -1. Notice again, the x coordinates stayed the same, but the y coordinates got opposite. Alright, number 3, double reflection. First over the x-axis, and then second over the y. I'm going to write both images for the first and second transformation. This is the pre-image. First over the x-axis, straight across. 1 above, 1 below. 2, 2. 2 above, 2 below. 1, 2, 3, 4 above. 1, 2, 3, 4 below. This is my image. And we'll call that image number 1. And let's erase that and spell better. Next, I'm going to reflect across the y-axis. So 2 to the left, it's going to be 2 to the right. 1, 2, 3, 4. 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6 to the left. 1, 2, 3, 4, 5, 6 to the right. 4 left, 4 right. This is image number 2, the final image. If I look at one coordinate, this is -4, 1. Going across that x-axis gives me -4, -1. Going across the y-axis gives me 4, -1. Notice, across the x-axis, x coordinates stay the same, y coordinates opposite. Across the y-axis, the y coordinates stay the same, but the x coordinates opposite. Alright, next, I'm going to reflect over the y-axis first this time, and then reflect straight across the x-axis. 2 left, 2 right. 4, 4 to the right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 4 left, 4 right. That is the first image. Next, straight across the x-axis, 1 above, 1 below. 2, 2 below. 1, 2, 3, 4. 1, 2, 3, 4. 2 above, 2 below. That is my final image. So this is the pre-image. Image 1, and the final image number 2. And notice, if I look at one coordinate, -4, 1, straight across that y-axis, +4, 1. The y stay the same, but the x is opposite. And then across the x-axis from there, I get -4, that's positive 4, negative 1. Notice across the x-axis, the x-coordinates stay the same, but the y-coordinates opposite. All right, next, inequalities. For this problem, I'm going to first make sure they're solved for y. They are both solved for y and ready. Once they are, remember, first number tells you where on the y-axis to put your first point. The number in front of x turned into a fraction gives me my rise and my run. So from that point, I'm going to go up 2 for my rise, over 1 for my run. Up 2, over 1. I'm going to stair step the opposite direction. That line, because of the inequality, will be a dotted line. This inequality is incomplete. Think of that as an incomplete line. All those points on that line will not satisfy that inequality. Next, negative 3 is where I start for that second inequality. Negative 1, which is that 1 right there, there's a negative 1 hidden there into a fraction, is negative 1 over 1, which means my run is positive 1, my rise is negative. So down 1, right for my run. Down 1 for my rise, over 1 for my run. Be able to stair step the opposite direction. That will be a solid line because of the inequality. Now for the shading, only one of these 4 areas is going to get the overlap. First one is less than, looks most like an L. That is below. So that dotted line, less than, is down below. I'm going to shade just a little bit. Next inequality, more than. More than is the one that does not look like an L. More than. So this line, shade a little bit above. I could see here is the area where they overlap. Nothing here. Here this goes up, but this goes down. In this quadrant, this is going down, but this is going up. Only in this quadrant right here are they overlapping. I'm going to shade that section in. So it's really clear that of these 4 areas, only this one has the overlap. All right, number 6. I'm going to solve this using substitution, and then I'm going to show you using linear combo method. So first step, of these 2 equations, this one by far is the easiest one to solve. I'm going to solve for y. And again, I could solve for either x or y, whatever is easier. When that's solved, the y tells me where in the other equation I'm going to substitute. Don't substitute this back into its original. That will not work for you. Substitute this into the other equation's y right here. So for my second step, I'll still have that 4x there, but where that 5 used to be, I'm going to substitute that negative 3x plus 5. And I have equal to 3. That is a 3 right there. So again, that's where that y used to be, but I'm using y for the other equation, and since these are equal, that will get the substitution process going. This will have to distribute. So I get 4x minus 15x. 5 times negative 3, negative 15. 5 times 20, or 5 is 25. Bring down the 3. Combine my like terms right there before I do any inverse operations. This gives me negative 11x plus 25 equals 3. Now I could start my inverse operations. So I'm going to do the opposite of adding 25. I'm going to subtract 25. These cancel away. Bring down the negative 11x. 3 minus 25 gives me negative 22. Next, negative 11 times x, the opposite is dividing by negative 11. These cancel away. Gives me half of my answer. X is 2. Remember, this answer always in coordinate form, the solution to the system. Put the 2 where the x used to be. Step 3 is taking that x is 2, and I'm going to substitute it right here so I could find the other part of this point. So where that x used to be, I'm going to substitute 2. The negative 3 is still there. Plus is there in the 5. Negative 3 times 2 gives me negative 6 plus 5. Gives me y is negative 1. And again, if I was to plug in 2 here, 8. Plug in negative 1 right here, negative 5. 8 minus 5 is 3. Plug in 2 here, 6. Plug in negative 1 here, 6 minus 1, 5. That point works for both. Now the linear combo method, if you choose this method. First method there is to find which point or which coordinate to eliminate. I'm going to choose to eliminate the y's. So what I'm going to do, I'm going to multiply everything by negative 5. If I do that, I'll get negative 5y, which will cancel away this 5y. So one of the easier adjustments to make. I'm going to multiply that negative 5 all the way through. When I do that, I'm going to take the time to write both equations again. So that bottom one, negative 5 times 3, negative 15x. Negative 5 times y gives me negative 5y. This is what I want. I want one of the variables to cancel. And then negative 5 all the way down times 5, negative 25. Now I'm going to combine them. 4 minus 15 is negative 11x. These will cancel away because they're opposites. 3 minus 25 is negative 22. Next, divide by negative 11. Gives me half of my answer. To solve for the other half, I need to choose one of these equations to plug that in. The easiest one will be to plug it in right there and solve for y. So where that x used to be, I plug in 2. Gives me 6 plus y equals 5. And now to solve for y, the opposite of that positive 6 is to subtract. And that gives me what y is. Both methods will work. It's up to you. Backside. This system is set up for substitution. Already solved for y. So this shows me I'm just going to take that and substitute it right in there to y in the other equation. So step 1 is already substituting. Where that y used to be, I have 3x plus 4 equal to negative 6. This combines to give me 5x plus 4. Make sure you combine like terms before you do any inverse operations. Now I could do my inverse operations. So the opposite of adding 4, subtracting. Bring down 5x in the equal. This gives me negative 10. Opposite of timesing by 5 is dividing by 5. Cancels away. And then watch your negative rules. Negative 10 over 5 is negative 2. Negative 10 divided by 5, negative 2. Make sure I put that in the x spot for my coordinate. Second step, take that negative 2 and I'm going to plug it in for x to solve for y. I could plug it in here if I wanted, but that would be a little bit more work. So my second step, where that x used to be, I substitute negative 2 there. I still have that plus 4. I still have that 3 out front. That gives me negative 6 plus 4, which is negative 2. Again, if you were to check that, it would work. Negative 2 right here for y. 3 times negative 2 is negative 6. Negative 6 plus 4, negative 2. Plug in negative 2 right here gives me negative 4. Negative 2 plugged in for y. Negative 4 combined with negative 2 also gives me negative 6. Alright, this one, the only shape with a set of all points equal distant, and sorry if I spelled that wrong, from its center is a circle. If I have the center and I take the radius, which is this length from the middle to the outside, and I make a circle out of it, every spot on that circle is the same distance from that radius. So a circle, definition of all points equal distance from the center. Alright, this one, the only quadrilateral that has congruent sides equal but different length diagonals is a rhombus. A square with 4 congruent sides has 2 congruent or equal diagonals. If I look at a rhombus though, a rhombus, even though it has 4 congruent sides which are equal, the diagonals, because it's slanted like that, are longer. That one's longer than this one. That one's shorter. This angle is different than this angle. For a square, all angles are equal and congruent. So for a rhombus, you could have equal sides but not congruent or equal diagonals. Alright, number 10. Which equation is parallel to G? Parallel means the same slope, the same number in front of x. These are all of these equations slopes that they're giving you to choose from. Slope of 3, negative 3, 1/3, negative 1/3. If I look at this line, connect any 2 points on this line, looks like I'm going down 1 for my rise and right 3 for my run. If I change that into my slope, which is always rise over run, it has a slope of negative 1 because I'm going down for my rise, and a run of 3. So that is a slope of negative 1/3. All I need to do is find which equation has negative 1/3 in front of x, and that would be D. That's positive. That's not 1/3 at all. So that would be D. 11, which is tied to problem number 10, says which equation is perpendicular to G. So the same G in number 10. I already know what my slope is, so I don't need to do my work again. Slope is negative 1/3 from that line in number 10. So again, I'm going to use that slope because I know that slope is negative 1/3. But perpendicular, which are lines not parallel, parallel lines go like this. Never will meet ever. Same slope, different y-intercepts. Perpendicular lines form a 90-degree angle. Perpendicular lines have negative reciprocal slopes. That means not only am I flip-flopping this, but I'm doing the opposite of it and making it positive. So I'm looking for any line over here with a positive 3 over 1, which is the same as 3. I'm looking for any one with a 3, and that would be A right here. The only line of all of these with positive 3. Don't pick this one. Don't pick the same. Alright, reflected over the x-axis. This is the x-axis, y-axis. I'm reflecting straight across that line. I'm reflecting across x. Don't reflect across the y-axis. It's not asking for that. X-axis. If point A in my pre-image is 2 boxes above, the new A reflected straight across. That's my new A1. B, the original B for my pre-image is 3 points below. I'm going to go exactly 3 points across that line of reflection. That gives me the new B. So my image is this right here. My pre-image, the original, forms an X. And then you can see A is 1, 2, where A prime is 1, negative 2, reflecting across the x-axis. The x numbers stay the same, but the y numbers become opposite. B right here is 3, negative 3. Going across that x-axis is 3, 3. Notice again, the x's stayed the same, but the y's became opposite. 13, a rotation. I'm going to use my paper. I'm going to trace and label A, C, and B. It says reflect about the point negative 2, negative 1. So when I find negative 2 for x, negative 1 for y, I see that it's one of the points on the triangle itself. So from there, I'm going to draw my little orientation arrow. I'm going to go 90 degrees clockwise. Clockwise like a clock is this direction. 90-degree angle is a right angle. So I'm going to take my pencil and I'm going to move my arrow until it goes 90 degrees. So I'm almost there. Right there is 90 degrees. I'm going to put my paper down, shift it a tiny little bit and see where my new points are. So again, I could see one point A is still there. That's the new A. But I could see on there C is down here. And then point B, let's check point B again. So go back. I'm going to fill this in a little harder so I can see where that is. And I'm going to watch that arrow go 90 degrees. So I could see right there at the origin is B. I could look through my paper and know that right here is B at the origin, and down 1, 2, 3 is the new C point. But I could really dig my pencil in, and when I lift it up, I could see those little marks almost went through that paper. So if I want to make sure which those are, this is B prime. This is still A and A prime. And then down here is the new C. And I'm going to connect those to make my triangle. So you can see it turned quarter angle 90 degrees clockwise. Alright, next. This one is a 90 degree counterclockwise, which again, opposite of the way the clock goes, this direction. So I'm going to trace that. A, C, B. I'm not going to take the time to draw that. I don't need to. I'm going to go at a 90 degree counterclockwise around this point right here. So when I find that point, 1 for x, -1 for y, I see again it is one of the points of the triangle. So I'm going to draw my little orientation arrow, and I'm going to watch it turn 90 degrees, but to the left, counterclockwise. So 90 degree turn would be right here. And again, I should have drew my line a little bit straighter. Let's fix that so I could really make sure I'm correct. Use my eraser, benefit of using a pencil. Straight up and down my orientation arrow. 90 degree turn to the left. I could see clearly it's the point -2, 0. But again, I could fill that in. This is -2, -3. This is the new C. This is the new B. So I lift that up. Again, I could see those little indentations where that was. I could double check. This is the new B. This is the new C in my image. And A is A prime again. Draw that. Label this as the pre-image, before the transformation. This is the image. So again, before the transformation, pre-image, after the image. Alright, next. This is how they're talking about their translation. -3 means I'm going left 3. Anytime the x number is going down by 3, you're moving to the left. Anytime your y number goes up by a number, that means you're going up. So for example, if I had this point right here, that's the point for x, 0 for x. If I go 2 boxes to the right, I'm at 2 boxes to the left, I'm at -2. Notice the x number went down, going to the left. Y number, if I went up by 1, that would be 3. When the y number goes up by 1, you're going up. So now this one, to find my new segment, taking each point 3 boxes to the left, and then from there 1 box up. That is the new D, D prime. This is 3 boxes to the left, 1 box up, the new C. So now when I draw that line, I can see that this went left 3, up 2. Alright, how many diagonals? I'm going to first use my formula, which is n times n minus 3 divided by 2. I'm going to count my sides. 1, 2, 3, 4, 5, 6, 7. I'm going to take that 7, which are the number of sides, and plug in 7 here and here. So I have a 7 there. 7, that minus 3 is still there, divided by 2. That gives me 7, doing order of operations inside the parenthesis first. Gives me 4. 7 times 4 is 28. Half of 28. 28 divided by 2 is 14. So I know when I'm doing my diagonals, which is a line from a corner to a corner, but not actual side, I need 14 of those. So I'm going to count to keep track. So first, I'm going to do each diagonal from a corner. I think that might work. So there's one diagonal. From that corner, 2 diagonals. From that corner, 3 diagonals. And then from that corner, 4 diagonals. So I could see from that one corner I have 4 diagonals. I have 4 of those corners. That's what's going to get, I'm sorry. I have 4 diagonals right here. And I have 1, 2, 3, 4, 5, 6 more to go. So that will give me my 14. So 7 times 2. I'm sorry, 7. All right, so here we go. So 1, 2, 3, 4. Next corner. 5, 6, 7, 8. Next corner. Oh, that one's already there. 9, 10, 11. Go to the next one. That one's there. There. 11 we're on. This gives me 12. 13. Next corner. Already there. Already there. Already there. So it looks like my last diagonal, my 14th diagonal to here. So again, double check. Look and see each corner. See if they're congruent. Congruent amount of diagonals shooting off from each corner to check. Start at one corner and go your way around. That would be my suggestion. Alright, 17. How many lines of symmetry? For this, you don't need to use a formula. You don't really want to try all your lines to draw like this to see if you cut it in half how many times. Symmetry for a regular polygon with all equal sides and equal angles is equal to the number of sides. So I just count my sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This will have 11 diagonals. That would be not something you would really want to try to draw. Alright, 18. Define my rotational angle symmetry. Again, when I'm turning this, how many times it covers itself up in one 360-degree turn. So I take 360, and again, one turn. And divide by the order, which again are number of sides. So there's 11 sides there. Divide that into 360. Divide the bottom number into the top. 11 goes into 36 3 times. Times gives me 33. Now I subtract. Gives me 0. 6 minus 3 is 3. Now I bring that 0 down and keep going. 11 goes into 30. Can't go 3 times. That would be too big. So I got to go twice. 22. Subtract. Here I got to carry. 10 minus 2 is 8. Next, I could add a decimal. Go to the next place over, which lets me bring down a 0. So 11 goes into 8. Not 8 times. That'll give me 88. So I'm going to go 7. 77. 7 times 11. Now I subtract. And let's go one more place. Bring down one more 0. 11 goes into 30 twice. So you'd see 32.72 if I'm rounding to one place. This 2 is not 5 or more, so that rounding number would stay the same. So I'm going to round to 1 decimal place. It's going to give me 32.7 degrees. Hopefully you won't have to deal with decimals. 19. This one, graphing this inequality, one of the harder problems on the test. Let me try to cover this up a little bit. Sorry about that. Alright, I'll just try to do it down here. This one, again, solve them both for y. So that first one, I'm going to have to do 2 steps of math to solve that for y. So I'm going to have to first subtract that 2x on both sides. Cancels away. Make sure you bring down that negative with the y right there. You don't want to write positive y there. Bring down the inequality. Nothing's going to make it change yet. Negative 2x plus 4 are unlike terms, so I just write them next to each other. Next, this is still not solved for y, so to solve this for y, I'm going to know that that is negative 1 times y. The opposite of timesing by negative 1, dividing by negative 1, I need to do that to both sides. Cancels away and leaves me positive y. Because I'm dividing by a negative number here, I have to flip my inequality around to keep my statement true. Remember, if I wrote 2 numbers like this, 4 is bigger than negative 2. But if I divide both sides by negative 1, that gives me negative 4 and positive 2. I can't leave the inequality like this anymore because, again, dividing by that negative 1 changed my numbers. So I have to keep my statement true, flip my inequality around. So now it works. That's why when you divide by a negative with these inequalities, the inequality switches. This negative 2 divided by negative 1, positive 2x. Be careful. 4 divided by negative 1 is negative 4. So that one has a y-intercept of negative 4 and a slope of 2 over 1 over 2 up 1, or up 2 over 1 if you want to do rise first. Next, solve this equation for y as well. So for that one, I need to subtract x on both sides. Minus x. Cancels away. Bring down the y. I am not changing the inequality. I did not divide by a negative number. Negative x minus 2. I write just next to each other. Remember, that's negative 2, negative x. This one has a y-intercept of negative 2. And if I know, again, that negative right there is negative 1 times x, that is a slope of negative 1, down 1, over 1. So if I graph them, here we go. First one, y-intercept of negative 4. So I go down to negative 4 on the y-axis. 1, 2, 3, 4. If I go up 2 for my rise, over 1 for my run, up 2 for my rise, over 1 for my run, that will give me the other points on that line. Stair step the opposite direction. Get in practice of doing that. This line, because the inequality is a plane inequality, without the line underneath, I consider it incomplete inequality, incomplete line. This is less than the one that looks most like an L. Y is less than 2x minus 4. Less than is below the graphed line. Next, this one has a y-intercept of negative 2. The number in front of x being negative is negative 1 over 1, so I go down 1 for my rise, over 1 for my run, down 1, over 1. Be able to stair step the opposite direction. That line, because of the inequality, will be a solid, complete line. If you were to check all points on the line would satisfy that inequality, the dotted line, those points would not satisfy that top inequality. And now for shading, this is y is more than, it's not the L, it's not the less than, more than is above. So for that line, more than is up here. I could see of these 4 areas, This is where they overlap. Nothing, no, right? This comes down, but this goes up, so there's nothing overlapping there. Nothing here at all. This goes up while this is shading down, so nothing in that top quadrant. This is the quadrant I'm going to fill in, or the 1/4 of that graph. There's 4 parts. This is the only one where they overlap. These points will work. I'm just going to do a quick check. I'm going to check 3, 0 right here, which is firmly in the zone. So if I take 3, 0 and plug in 3 for x and 0 for y, it should satisfy that top one. Plug in 3 for x, 0 for y should satisfy that bottom one. Plug them into both. So that top one, where x used to be, plug in 3. Where y used to be, plug in 4. Gives me 6 minus 0. 6 is greater than 4. True statement. Plug in that into the bottom equation. Gives me 3 plus 0. That gives me 3 greater than or equal to negative 2. That one works too. If I pick a point on the dotted line, what will happen is it will work in one but not the other. 2, 0, if I plug into that top one, gives me 4 greater than 4, but that is not true. 4 is not greater than 4. If I plug in that into the other one, and use my handy eraser there, that is a true statement. That satisfies the one inequality, but being on that dotted line does not satisfy both. You need a point firmly in that zone to do your check. Alright, my constructions. Bisect the angle. I'm going to adjust my compass so I could connect. I'm going to go about this size, a little bit smaller than I did earlier today. Connect those 2 rays. Firmly have that pivot point in there. Put more weight on this pivot point right there. So I'm putting more weight in the tip. Next, I don't want to see anyone do this. Don't put that tip up here and then immediately draw your little arc up here. I will be looking for that. Don't do that. Take the time to stretch out your compass. So again, make sure you measure this angle. So I got to stretch out my compass a little bit. Now I leave the tip up here where this line or this circle intersected. So I put my tip right up there and draw an arc. Next, switch it so the tip is way down here where it intersected way down there. Put my tip in, more weight on the tip. Draw another arc. Where that arc intersected with the other one, now I take my straight edge and go straight through there. You will have more room on the test. These angles are equal. That line bisected that angle, cut it into 2 perfectly equal angles. My construction marks up here, which I will be looking for, again, I can clearly see they were longer than this. Full credit. Perpendicular bisector, a line that cuts through that at a 90-degree angle, cuts that line segment in half. Take my compass, make sure I measure over half the distance. Firmly put the tip in, more weight on the tip. I'm going to draw about a quarter of a circle, half circle almost. Switch it so the tip is over on this side. So again, firmly put that pivot point in there. Keep that tip down. More weight on the tip. Draw your other half circle. Now, if I could see you put coordinates or little points where they intersect, take your straight edge and you're going to go straight up through those points. Don't take the time to do this and then have your line be off. You don't want to do that. So this perfect 90-degree angle cuts these line or this line segment in half. All right, last one. the rhombus. So for this, I'm going to construct a rhombus, a four-side congruent quadrilateral, using this length. So I'm just going to take my paper and I'm going to straighten it out, make my life easy. Take my compass, measure it that exact length. You want all the lengths to be that size exactly. Now I'm going to draw my half circles. So from that, with a tip at the end, I'm going to draw one half circle. Next, I'm going to switch it. So the tip is over here, and I'm going to draw another half circle. Next, I'm going to pick any point on one of those circles. I'm going to stay close to here. I could either go a little bit to the left here, a little bit to the right. You don't really want to go way over. Probably stay maybe about this distance right here. That will be my third point. Guaranteed to be this length because, again, that is that radius. So that is exactly the same. Perfect size rhombus. All I need to do is take my compass and swing it through here. I could see it needs to intersect with that circle, so I'm going to go back and extend this circle a little bit longer, which I should have done at first. Now what I do, again, this length equal, this length perfectly equal. Now if I take my compass, put my tip up here, and draw another circle with that radius, again, that will have the perfect rhombus, all four sides equal. So again, you can see that length is equal, that length is equal, equal, and then my new point equal. Fill that in, grab my straight edge, connect all those dots. And as my rhombus, all these sides are congruent. They're all equal. This has non-equal length diagonals, though. You can see that one is shorter than that one. If you want to do your construction for your compass, for your rhombus a little bit different, you could use this. Draw your two half circles. And pick a point down here. Take your rhombus and swing it through. Oh, there's nothing to swing it through, so I'm going to go back, extend my lines. There we go. Now if I go back, I could take this and swing it through. Again, I'm trying to swing it through one of these circles. If I swing it through right here, again, you can see my rhombus, four equal sides, equal, 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 and equal. I got a little ant right there, watch out. So now if I fill those in, that has another look to it. Again, equal, but diagonals not equal. All right, I hope this helps. Good luck. Okay, to prove to me that you watched this whole video through, your homework is to do these problems and do the extra things I did. I did a few extra things. So to prove to me that you watched this, I'm going to have you do a few extras. For example, For my reflections, I'm going to have you show me something that you listened to this, that you saw that reflecting across the y. The y stayed the same, but the x's became opposite. I'm going to be looking for that check. Where did I put that check? That's weird. Alright, but again, I'm going to be looking that you're doing problems like this and doing the check, plugging in that number, and showing me that that point satisfies both inequalities. True statement. True statement. All right, good luck.